Welcome back to the Grand Solar Minimum channel. Today is August 6th, 2017. Quickly, I wanted to go over solar conditions. Our solar wind speed sitting at a 558.9 kilometers per second with a density right around 5.1. And we were feeling the effects from the coronal hole that we had from August 4th. That is well exited to the left. Looking at sunspot number AR2670, which once was 2665, much smaller as well. In fact, when this came back around Earth side, it was only a fifth of the original size. Looking at KP indices right around 2, the 24-hour max was unsettled. And of course, currently looking at the SDO, we do see another small coronal hole in the equatorial region. I can only imagine that we will see the effects from this coronal wind stream within the next 3 to 4 days. So, Lee, thank you for joining us. It feels like it's been a while.
Yeah, it has been a little while. Can you bring up your audio just a little bit? I'm having a hard time hearing you.
All right, is that any better?
Just a little bit, yeah. Thank you.
All right, sorry about that. All right, so tonight we have a couple things for everybody. We have a couple of videos we wanted to show that talk about the key factors of the Grand Solar Minimum. And first, I want to start off the show with some images that I had snapped myself here in Western New York. And this was not a normal rainbow. I didn't have the arc that most rainbows had. And I immediately snapped a few shots of this and called Lee. I hadn't seen a rainbow that was situated the way this one was. Is that up, by the way? So basically, I was just wondering, Lee, if you could pause that right there for me, Mari. This was what I took right here, and if you could, Lee, just describe to everybody, this wasn't the typical rainbow. There was no rain falling at the time, and this was not at sunset either. So just if you could explain to me, everyone, what we were looking at here.
So what you're seeing is you have particles in the atmosphere at a high enough altitude, a high enough humidity, and the particles are large enough from 50 nanometers up to 100 nanometers, whether that be a gas or what have you. Anything that is that size, even a molecule, can work as a seed for a raindrop. And so what you're seeing is as the particles are coming down through the atmosphere and they get to the right altitude for the right barometric pressure, the right temperature, the right amount of humidity, they are drawing that moisture in an atmospheric compression, because this is how it works. The particles come down, and as more particles come down on top of one another, you get layers and layers of moisture. And so as that bottom layer is working its way down, that's what you're seeing is the light is just catching the bottom of that layer. You're not straight onto a layer of moisture where it gives you a very defined rainbow where you're looking straight in. We're looking at a layer or a wall of water that is more horizontal, or a layer of moisture that is more horizontal than vertical. And as the light hits that, you get this diffused rainbow like you're seeing right there. It's not as sharp and as defined because it's not just moisture all the way to the ground. That's why it looks that way and diffuses as it goes off onto the horizon.
Yeah, and it wasn't raining at the time, and I also saw another comment in the comment section. They also seen a 2 cloud rainbows at the same time this week, no rain. So again, that was more than likely, again, what they were witnessing was the atmospheric compression coming down. And Lee, we've got this little clip of video that Lee had brought to me. Basically, this talks about different factors of the grand solar minimum. Lee, have you reviewed this video?
Yeah, just once. Basically, all I was doing was looking for something that just gave us the main contributing factors to what will be coming in the grand solar minimum. And so this video covered some of those. And so, I figured it would give us some data points here to look at while we were going through it and while we were talking about the different contributing factors to the coming colder climate. So, that we're in our third major cooling period in the last 2.5 million years. We have ice on both the north and south. So technically we are in an ice age because we do have permanent ice on the planet. Okay. There have been times where there is no ice anywhere on the planet, and there have been times when they had ice all over the planet. So pause it right there.
Okay.
So you can, that was our first mini ice age. This is the second mini ice age. So you can see back there, that was the first one in 1650. And then we've had another one, since then. And when you look at the charts that we'll get into here a little bit later, you'll actually be able to see the curve that I'm talking about and the decreasing energy within our solar system. And so, yeah, there's a mini ice age. There's another mini ice age back in 1850. Okay, well, and then, we've had, in 1640 to 1750, rivers, the Thames, New York Harbor were all frozen over, or the Thames, Thames,
Yeah.
So we've had a variety of this type of weather in the past. We're not talking about anything that has never happened before. What we're talking about is this one here has a good chance of being worse than the others, just simply because of the contributing factors and where we are within, our cycles. And so, there's a variety of different things, so where we are, the decrease in solar activity that we're having, the increase in vulcanization, as well as an increase in seismic activity, the gravitational pull of the gas giants, and more than 50% of the planets being on one side of the solar system, aerosols in the atmosphere, that are interacting with galactic cosmic rays. So there's, a lot of things that are going into this.
I was looking at this video, and there's a lot of information. I wish there was a slow-mo video motion. Show back to the first, the second part there. I think it was number 2 on our. There's a delay.
Solar activity?
Yeah, solar activity decrease.
Okay.
I wanted to pause that real quick and talk about the solar activity decrease and what that means. A lot of folks have had some confusion because they've seen the solar flares and the CMEs that were released on the other side of the sun. And Lee, we briefly talked about the magnetic field on the other side of the sun right now and how unstable and weak that is over there versus over here. It seems to have its act together a little bit better, which we believe, or at least I think what we believe, is that the chance of a CME strong enough to do the kind of damage that people thought that one on the other side of the sun did. Is that possible with the current conditions right now?
Not with where we are within our orbit.
Right. And that's the key factor there, the orbit.
Right. Yep. I have my own theory. I asked Valentina Zarkova about this in our interview the other night, or the other morning, and she couldn't answer me. And I'm having a real hard time finding anyone that can answer this because, I'm at the realm of what we understand. So, it's kind of hard to find somebody that can give you a definitive answer because nobody is really 100% sure about anything. But, my hypothesis on this is that when you have all of the gas giants on one side, all of those are contained within a 90-degree or 45-degree field of view from the sun. So if you're at the surface of the sun and you're looking out, all of the gas giants are within 45 to 90 degrees or less, all gathered together. Greater than 50% of the planets are on one side of the sun. When this current situation exists, and you can look back through history and see this in different planetary alignments and CMEs, but it tends to, and I can't say it does it 100% of the time, but you tend to have more CMEs out of the opposing side of the sun from those gas giants. And when that happens, my hypothesis on it is that all of the gravitational effect of all of those planets on one side, and you can't say that it's not significant because it moves the sun, people. So if it has enough gravitational effect to move the sun out from the center of the solar system just so slightly, I would think that the magnetic umbrals, with the particles that are in those, which are also governed by gravitational forces and magnetic forces. Of course, magnetism is much, much, much stronger than gravitational pull. But I would tend to believe that with all of that gravitational pull, all on one side, that you would have just an ever so slight increase in magnetic density on that side as it tries to pull those magnetic fields around, all things being given equal. And on the opposing side of the sun, it would be slightly weaker, so as that when deformities within the surface of the sun, otherwise known as sunspots, progress across these areas which have slightly weaker magnetic fields, if they have the potential to flare at that moment, they will. This explains, when you look at most of these CMEs going back through history that are on the opposite side and didn't hit us, it helps explain what is referred to as the Earth-facing quiet, which has again shown its face as what used to be 2665 is now 2670, comes back across again, it simmers back down just like it did previously. So, that's my hypothesis on it. If there is an astrophysicist that is watching the program and or someone who is extremely educated in magnetic umbrals and field lines, I have several things that I would like to run past them. But that is one of them, and would explain why we have what is most commonly referred to as the Earth-facing quiet. Now, the problem with that is, and as Valentina Zarkova talks about, that the sun will become weaker, all of it will become weaker. So I personally think the likelihood for an event such as a Carrington event is more likely when we are on the opposite side of the sun, like we'll be in December, January, and February, as opposed to where we are right now.
Right.
So,
and I'm glad you mentioned that, because that's kind of what we did when we first talked about this off the record. Amari and I kind of played around with Solar Scope, and that's funny that you mentioned January, February, because that's where we kind of came up with our what we observed as well. The Earth will be in a position that would be vulnerable to a situation like that, I guess. So, but
yeah, no one can say that it will happen.
Right.
We can just say that there's a slightly greater chance during that, based on the research that I have done and the coincidences of where the Carrington event and other events of where we have had CMEs. If you look back on Solar Scope and other, you'll see that we just tend to get banged around a little bit more when you have all the gas giants on one side and we're on the other side. Just works out that way. Whether my hypothesis is right or not, we'll determine when we speak with more experts and kick it around a little bit, throw it against the wall, see if it sticks. But, if you look back in time, again, like the Carrington event and others, you will see that when we're on the opposite side of where they are, we get a few more ugly situations than we normally have.
Hey, Lee, I wanted to interrupt real quick. There's a question in the comment section, a good question. Ziggy asks, at the moment, we have hot and cold extremes. Do you expect the heat extremes to fade away over the coming years?
No, I do not. And in fact, they won't. There will be some areas of the United States that will actually become warmer. So Alaska becomes warmer. There's a region out in the northern Atlantic, just off the eastern seaboard of the United States, that becomes warmer. But there are also places that become 10 degrees colder. So, these areas, bubbles of heat, that is just a high pressure area that just decides to sit over an area for an extended period of time and bake that area. What we're going to see coming, the hot weather is not going to disappear. There will just be more cold weather, and cold weather extremes and extreme weather. And then when you get into the cold part of the year, the winter time, you're going to freeze your derriere off. Because when these cold polar vortexes come down, and as the Arctic area of where the Arctic air normally stays, as that expands down closer to the equator, people who aren't used to dealing with such cold weather or deep snow are going to have a real problem, because as it moves further south, there's going to be more tropical air that wants to come up into that, carrying moisture, and you're going to have extreme cold air coming in against extreme amounts of tropical moisture, which is going to amount to very significant snowfalls that can last for days. I mean, at 32 degrees, 30 degrees, 28 degrees, along in there, you talk about, you get a foot of snow for every inch of rain. But if you drop that temperature significantly, where you get it down into the teens or close to zero or below zero, and you get that fluffy, powdery snow, now you're talking about possibly a foot and a half of snow for each inch of rain. But let's just go and say it's a foot for easy math, and guaranteed you're going to get a foot out of an inch. So we've had rain events where we have seen 4 inches of rain in an hour and 7 inches of rain in a day. There have actually been places where they have gotten 12 inches of rain in a day. And some of those places are places where they also get snow. Parts of West Virginia is an example of that in the flooding that they had here last year. So if it's an inch of rain a foot of snow per inch of rain, and you get 4 inches of rain in an hour, that's 4 feet of snow in an hour. What do you do when it's snowing like that? And then what do you do if it decides to do that all day and you end up with 12 feet of snow? So, these are the conditions that are going to come along. Just like the farmer that they interviewed just the other day, I saw, where he's in Kansas and he grew wheat, corn, and I think barley. Or no, excuse me, soybeans. So they had the storm that came through back in June, I believe it was, and it wiped out his wheat crop. He was decimated by the fact that it wiped out his wheat crop. And he said back then, thank God everything wasn't wrapped up in the wheat crop. I've still got my soybeans and I've still got my corn. Well, 2 days ago, a storm came through, did hail damage, and pulverized all of his soybeans and pulverized all of his corn and destroyed his entire crop, 100% of all 3 different types of crop that he was growing. And he said, I'm done. This year, I have lost more money than I have made in the last 5 years. And so he's throwing in the towel. That's just a prime example of the weather that's going to be coming. So it's extremes that come in and wipe out the crop. It doesn't have to be cold all year. You just got to have one hell of a hailstorm for 15 minutes. And it'll destroy all of the crop, and it'll destroy all of the cars, like the 170,000 cars that were destroyed in China in 15 minutes. And, you know, we had one hailstorm that came through and wiped out an area of 250 square miles. Okay? All of the crops in that 250 square miles were decimated. Somebody said that it looked like the hand of God had came down and put his finger on the fields and just wiped it across, because it's just bare dirt where the hail came through. There is no plants. I mean, the people have not seen what is coming. The news does not do it justice. You know, when buildings are being destroyed, siding is being ripped off of buildings, awnings are being ripped down. You have water, you have hail that is 4 feet deep. It melts, and then you have raging torrents flowing down through cities.
Flash flooding everywhere.
Oh yeah, that's not even counting the flash flooding, the snows, the fact that we're coming into where the volcanoes are going to start erupting, and they will drop the temperature globally by a degree or 2 Celsius, all on their own.
Well, Lee, that's a good point that you just bring up there. Dappa Dave had a question for you. He was asking if CO2 levels decrease during the grand solar minimum.
No, not really. CO2 follows the warming trend by 800 years. And that's varied when you go back, you know, over 20 million years. I think is how far they can go back. Well, over 2 million years. But when you look at that, normally CO2 follows that. A lot is absorbed into the oceans as we get cooler. My God, termites put out as much CO2, if not more than we do. So yeah, there's a lot of things. Oh, even mushrooms put out CO2.
And I wanted to follow up real quick with his comment while he was waiting for us to ask the question. He put, during my year at the South Pole, we ran out of CO2 and we lost our plants. 55 humans could not exhale enough CO2 to maintain a 15 by 20 by 10 grow room.
Wow.
Yeah. So that's interesting there.
Put some mushrooms in there. Put them in dark boxes. Just keep them warm enough for the mushrooms to grow. They'll increase your CO2 level.
How many? How much mushrooms?
As many as you can. You can't overtax it. Never happen. You can't put enough mushrooms in there to make it toxic, because the plants will eat it. So if you go underneath all of the trays of the plants and you put boxes underneath, they have a couple layers of mushrooms underneath, it'll really help on your CO2.
All right, Murray, go ahead and play the next. I got some charts here.
Yes, that's the long-term trend that I talk about. So, you know, people say, can you back up there, boss? Was that the first one?
That was the first one.
Yeah.
I can't.
So people say, you know,
It's stuck on this.
Lee, it's an 11-year cycle. Well, yeah, there is those two.
That's what it's been stuck.
And then you say, well, Lee, there's a 206-year cycle. Well, yeah, there is those two. And then you got the 3,000-year cycle. And, well, yeah, you got those too, but that's not the one I'm talking about. You see that long green line going through there and diving off down here towards the bottom corner here?
Yes.
Okay, well, where that enters the screen there, that's 9,925 years ago. So as you can see, that is a much longer trend than 3,000 years.
Right.
That's the trend I am talking about. That is what the sun is doing, irrelevant of all of these other cycles. People can say, oh, well, we're going to come back out of it in 30 years or about 2050. Well, you look at that green line, and you just estimate where it's going to be in 2050, and you just say, well, is that going to be above where we are now, or is that going to be below where we are now? And you ain't got to be a rocket scientist or much more than a 3rd grade education to be able to see that, according to that trend, more than likely we're going to be colder than where we are now.
I used to have the idea, the theory that we could do a soft landing in this, and just in the last 2 months, I don't know if that's possible. Last month we reported about June's temperature was a plus 0.21, and then they came in this month slightly above, but even Dr. Spencer mentions that we are still below where we're supposed to be for August as far as heating goes, in July especially. So, you know, like I said, when we first started getting going here with this channel, I was hoping that this could be a soft landing, and I don't know if there's a such thing as a soft landing for this right now. I guess there is, just because we've started talking about it now, but things are definitely accelerating. What's this?
Well, there
chart
won't
right
be a
here?
soft landing for the Earth. Okay, and there won't be a soft landing for the inhabitants of the Earth. This thing kind of like works like diving into a swimming pool, and you can dive in so deep. And actually, if you move forward on the next chart here, I think we might be able to see it there. I don't know which chart is your next one, but yeah, here we go. Okay,
This one's my favorite. This one's probably
it's one of my favorite. One of my favorites too. Makes it real clear to what's going on. But my point is, you see how when you go to the left side of the screen, you got the kind of the red hump, and then it comes down into the blue and just barely goes down in, and then comes back up, and then starts coming back up in the red. Well, if you move that up, so is at the bottom of that little loop right there is the line going across as far as like the 0 line, which is 57 degrees Fahrenheit. See that line right across the center of the screen? Yes. Okay. So if you take a sideways view looking into a swimming pool, and you see a professional diver dive off of the high dive, and they come down and they dive into the water, and then they pull up and they swim just above the bottom, and they come back up to the surface. Okay? If you have a solar cycle, one back to back, and you call the bottom of the pool the 0 line, as far as the number of sunspots, as long as you never get down below 0 sunspots at the solar minimum, you don't have a problem. You don't hit your nose on the bottom of the pool.
Right.
Okay? The problem we've got is we're already seeing 0 sunspots, and we're not at the bottom. We're not done with our dive. We're still downward. We're not scraping our nose on the bottom of the pool. We're hitting the bottom of the pool head on, because we should have started pulling out long before now. So if you look at this chart and you look back to all of the minimums and where we are now, and you look back, where it was very cold during the Little Ice Age, if you notice the bottom of each one of those blue dips right there, they go a little deeper each time.
Yep.
That is the trend that I'm talking about, of that green line. And so they can say, oh, it won't be worse than the last, Little Ice Age. Well, it was worse than the Dark Ages. And, so it's going to be worse this time if the trend holds true. And when you look at the trend over 9,995 years, or whatever that other chart had it back, well over 9,000 years, the trend is pretty solid. The trend here, only going back, 2,500 years, is, fairly solid, or 5,000 years. So it's easy to see, where we are. So from 2,500 BC, so we're 4,507 years, or, actually it would be 17 years. But if you look at that, you can see that we're going deeper on the right side. And that is what we're going to continue to do. And that's why I tell people it's going to be colder. We're going to have increased galactic cosmic rays. We have increased aerosols in the atmosphere. We're continuing to stick more aerosols into the atmosphere. Doesn't matter if we burn coal or whatever, that's just going to make us colder, because any particulate that you stick in the sky, when it interacts with galactic cosmic rays, you get the possibility of more cloud nucleation, or probability of additional cloud nucleation. So when you take it all into effects, if everything was identical with a little ice age, just simply because we have more particles in our atmosphere, we will be colder on average.
Got another question for you here in
Sure.
the chat. It's Steph. Question for Lee: what are his thoughts on Earth's magnetic pole shift in relation to the grand solar minimum? Is there a connection between the two events?
No, I think they are totally separate events. I don't think that they have not coincided with each other. They are not on the same cycle pattern. The grand solar minimum will be over with before the magnetic reversal takes place. The magnetic reversal actually acts like lava in a lava lamp, and we have pieces of our core that have more northern than southern, and so on and so forth, and it moves around like lava in a lava lamp. So it actually won't be where the North Pole runs towards the South Pole and the South Pole runs towards the North Pole, and they go in opposite directions. They're going to pass each other. The North Pole is moving much faster than the South Pole, and the last prediction I heard where they were going to pass each other somewhere in the Indian Ocean. The North Pole is moving much faster than it was. The other thing is, when it happens, it doesn't just flip over and that's it. It's been recorded that it'll flip over and back and over and back and over and back, and have done it as many as 8 times before it finally decided that it was going to do the final reversal with what it stuck with. And they know that because they have went back through and pulled lava that had set up from magma during the reversal periods, and they can see in the exact same flow of lava where the magnetic field was flipping back and forth as it was cooling. So that's I'm not concerned with the magnetic field. It's going to screw with some of the animals that use the magnetic field for navigation. It's going to screw with people with maps and things of that nature. Will it cause all of the continents to shift? I don't think so. Will it cause the oceans to rise up and take over the planet? I don't think so. I just think it's going to flip to the other end, and anything that uses navigation by magnetic fields, like birds and turtles and other things like that, they're going to have some getting used to get used to it. But it's going to happen over a long time. It's not going to be something that happens in 5-10 years.
Gotcha. We got the chart up right now that shows the sunspot count, and I noticed each time they keep updating this, we're further and further below the projected line in the first place. What are your thoughts on that?
Well, they keep moving the line down too. They keep,
yeah, they
going,
do.
You're a foot short, and we started out at 30 feet, and now we're down to 2. Okay, and actually, in all practicality, we started out. This was supposed to have been a solar cycle, according to NASA, that had 175 to 225 sunspots in it. Was NASA right? I don't think so. We got to 100 at the peak. That was the second peak. Now, the crazy part about it is they keep lowering. You see the red line in the lower right-hand corner. You see where it comes over and it hits the year 2019? Well, that's where they thought we were going to be at where we are now. So, we are 2 full years ahead in the decline of what was estimated by the experts. And by the way, the one that NASA finally went with, which was like 75 or whatever, is John Casey's prediction. So wow. NASA changed their prediction to match John Casey's, and we're falling short here ever so slightly of John Casey's.
And looking at the graph in comparison to solar cycle 23 and 24, we're barely halfway down the decline into the bottom. So I mean, it looks like zero. I mean, what was the peak for the next solar cycle? Was it 50 or 75?
It's going to be between 50 and 75. It depends upon who you ask. Honestly, if you count sunspots the way that they used to count sunspots, and I got a beautiful video on that a guy did who actually went back and counted every single sunspot since like 1610. Okay, and he's counted all of those sunspots, and he and his team of, PhD astrophysicists, and they counted them the way that the people used to traditionally count the sunspots. And what they found is, if you take a sunspot that you see on the sun today, and you count it the way that it used to do, they used to count it back in 1610, or you count it the way that NASA counts it now. The way NASA counts it, it'll be 15. The way they counted it back in the day, it'll be 1. Now he's got a full over an hour lecture describing how all of that math is done and the painstaking work that he and his team went through to prove that. I'll put that in our playlist so people can go there and look at it. It's actually in my favorites list. But when people talk to me about sunspot counts, if they haven't reviewed this man's lecture and all of his team's work, it's very difficult for me to communicate with them about sunspots, because they just go by the number that they see from NASA or the Royal Observatory, which is skewed due to averaging, which I think is the biggest pollution to science in modern day.
Lee, I'm going to keep you moving here. We got a lot of great questions coming in from the chat.
I love the questions, people. Keep them coming.
So we got one question here, and please forgive me if I don't get to all these questions. I'm scanning through the chat here, but Kuiper X, if the grand solar minimum gets colder each time one occurs, will it eventually hit a tipping point and trigger a more prolonged cold era?
Yes, but it's not the grand solar minimum that does that. And this was a show that we were going to do. Actually, we had talked about doing tonight, but we're going to do on Thursday. And that is, our sun is powered by electricity that comes in through the universe. And that is not a constant. That varies. And, people in the electric universe theory will say, oh, no, that's not part of the electric universe theory, that the sun can fluctuate that much and go dim. Well, I'm sorry. If you're part of the electric universe theory and you don't know that, you need to do some more research and do something like plasma density, plasma energy, how plasma change states, and go look at the Sapphire project and what happened when they varied the input voltage to the plasma during that project. And then look at the effects of that, which are catastrophic, because the sun has the ability to emit a huge EMP as it changes plasma states. If you want to look at what it'll look like when it does that, look at Dr. David Talbert's work from the Thunderbolts project. I've reviewed everything that he has put out in the last decade, at least, if not longer, and reviewed it multiple times. He has a huge collection of hieroglyphs that have been painted all over the world. So every culture on the planet has seen this when the plasma discharge drops down, and you have the bowl currents on the ends in the plasma. And we'll talk about that more in the show on Thursday. But basically what it amounts to, and it's Dr. David LaPont is also who has done some research into this with plasma, and he can describe and see these hieroglyphs that were created out on the deserts and many other places where you see the man with the circles on either side of his torso, and his arms are up and his legs are spread and sticking down. Some of the figures, it looks like a duck on the top of the head. That's the angle of it from where you are looking at it. So, all of this is explained. All of this can be explained. It's a lot more than I can explain in tonight's show. That's why I highly encourage everyone to come back on Thursday night, where we will be talking about specifically that and how the sun is actually charged through currents that travel through the galaxy. And we're charged by the spiral arms of the galaxy. And by the way, the trend that you saw there in that green line that I was showing you is that energy level that we pass through as we travel through the galaxy. And that energy level is what we oscillate off of. And so, and when you look back in ice cores and so on and so forth, there are times that it has shown that the sun has shut down in 24 hours. And that's how you get elephants, or excuse me, not elephants, but mammoths with clover frozen in their mouth, buried in the snow. Because when the sun goes through a solar shutdown, and I'm not the only one that says this, Roof Weche from Canada says it. There are many other people who say it around the world. David LaPlante's work, the work from the Sapphire Project, and many other plasma physicists' work around the world, plus all of the research I've done on plasma physics, says this is what plasma does. These are the laws of plasma. And so you can't decrease the power without having this transition. Doesn't work that way. So anybody that thinks that that is not part of the electric universe theory, I encourage them to do the research that I have done that shows that it is part of the electric universe theory. And that's the way it has to work.
I got this chart up right now, this graph that shows the global temperatures, the lower atmosphere temps. And we have a person in the chat. He's been here several times. He continues to tell us that we're not cooling. It's not happening. But yet, when you look at this graph right here, and this, I mentioned this earlier, how we were at a 0.21. We warmed up a little bit, 0.28 for July, but these numbers are low for where they're supposed to be. And I wanted to bring this chart up to everyone because to me, what I'm seeing is a trend that's going down. As far as we might be above, we might be in the surplus right now, but we're in the very beginning of this grand solar minimum, and you can already see the steep decline. These temperatures are dropping each month.
Well, all right, look at it. We're at July, August of 2017. Okay? In January of 2016, we were at 0.88.
That was February.
Or is it what, February? Is it what it was? Okay.
Yep.
Anyway, so February, we were at 0.88. Now we're at 0.28.
Right.
That is 0.6 degrees Celsius. That's more than a degree Fahrenheit that the planet has dropped in just a year and a half.
Yeah.
Okay? So you tell me, when was the last time the Earth dropped a degree in less than 18 months? You can look back on the chart. That's not there anywhere.
No, it's not.
Okay? So, you know, and this chart's going all the way back to 1979. We can go back way farther than that. The only time you will ever see it drop like that is, ta-da, at the beginning of a grand solar minimum. This is yet another trademark of what transpires. So look back when we went into the Dalton. In fact, we're still going steeper than any other minimum that we've ever fallen into.
Absolutely. I mean, looking back, you know, we had a weird, I remember the 99-2000 winter. I remember the ice storms. I lived in Ohio at the time. That's the last time I've seen a temperature drop as steep. And of course, back in the 70s, especially late 70s, we were throughout the 80s, really not until about the mid 90s when we started to warm. But clearly the graph is not indicating that it's trending back up by any means. And again, looking at this report here, Dr. Spencer, by the way, gives this every month on his website at drroyspencer.com. I recommend it. It's good information. He is a big advocate for CO2 not driving the climate, and just another scientist that we can throw into the basket here of people who agree with what Lee and I believe, and mainly, you know, thanks to Lee to get me on that track. But so I hope this helps people understand the where we're getting the info. This is the data that we're looking at as far as how we know our temperatures are dropping. You know, aside from the science of the grand solar minimum, with the weakening of our magnetic field, allowing more charged particles into our atmosphere. And speaking of that, there was a question I wanted to ask. Summer BC asked a question about colors, and bear with me, I'm scrolling back here real quick. He had a question that dealt with Aurora Borealis and their colors, and he asked, what do the different colors of auroras mean? Is purple and white bad?
Well, it depends upon the color of the gas, or excuse me, the color of the light is determined by the gases that are being ionized and the pressure of which those gases are being ionized and the mixture of those different gases. Now, if you'd asked me before July the 7th what the mixtures of those were, I could spout them off to you, but since I've had my strokes, I don't remember them right at this particular moment. But I do have videos on that, and I will go back and review that and remember that and be able to bring that to you, and I will also put that into our playlist. But it's the different gases. So you have oxygen and nitrogen and other gases at different altitudes and pressures at different altitudes. And even the same gas can give you a different color at a different altitude because it's a different pressure. But when they are higher up in the atmosphere and way up there, and blues and whites and so on and so forth, those are highly charged atmospheres, because when normally you just see some greens and some reds, but when you see some blues up there, and we talk about the sprites and we talk about the gnomes, people didn't used to see sprites. You go back 10, 15 years, nobody, a sprite was a soft drink. They didn't know that that was something that shot out of the top of the clouds, or out of our atmosphere into the stratosphere and out into space. I had made predictions about when we would start seeing those. I did not predict that you would capture, an amateur would capture 9 sprites at a single photograph.
Hell,
I didn't
Ray
predict
Charles
that would happen until 2020, 2021. I didn't hear that, Jake.
It was a really bad joke.
It was a bad joke. Don't
worry.
worry.
Didn't hear it. He already played that joke on you yesterday on the phone.
Oh, okay. Well, anyway,
I made the comment. Even Ray Charles saw it when the 9 sprites were located in the sky. But
yeah, absolutely. Him and Helen Keller have been talking about it all weekend. So, it's a heck of a thing for people to be able to see that. And the scary part about this is let's look at what our ionosphere is doing. We're losing charge in our ionosphere. Now, space has its electrical potential, and the Earth has its electrical ground. And so that charge difference potential is staggered across our atmosphere, troposphere, ionosphere, magnetosphere, all the way till we get out into space. Okay? And so if one of those layers is losing its voltage potential, that means that the voltage potential between space and Earth over the other layers will be increased, which means that we're going to have bigger lightning. We're going to have more positive lightning, and the lightning will be much, much, much more devastating and much more frequent. So the amount of lightning, and we're going to have some changes coming around within our Schumann resonance as well, just like we're seeing, and I predict that will continue to go more cattywampus as we move further into this.
Okay, and I'm going to keep it moving here.
Yes.
Another question here, and I think Matrix 369, she was asking how will this affect us physically and what timeline, and I think she means the effects of the grand solar minimum. I don't know if there is a timeline or how this will affect us physically, because I think it'll affect different parts of the world at each certain time. But Lee, do you want to take a stab at that?
It will affect all of us physically, because we're all going to get hungry, folks. That'll be the first thing. More crops will fail. Crops will not mature. They will not come to maturity. Crops will not come out of the ground because the ground won't be warm enough to get them to germinate in the season that they normally will. The amount of sunlight that they get during the day will be decreased because of the increased amount of cloud cover will decrease the amount of TSI that falls on each plant, which will reduce its yield. you'll have more mold problems because you'll have more cloud cover. It won't be burning the moisture off the plants from the morning dew. The dew will stay on them the most of the day, and you're going to have mold and rot all over your plants. You'll have ground that won't dry out, so your plants can't grow. So you're going to have raised beds that have French drains in them, which is something that I've been designing for farmers already. So there's going to be a lot of different things, but yeah, the first thing that we will see is starvation and more volcanic activity and more seismic activity, and the detriment of those substantial volcanic activity events, as well as the unbelievable seismic activity events that will take place both here in the United States and abroad within the next 4 years. We're going to see some catastrophic, my prediction is we will see some catastrophic earthquakes within the next 4 years, as well as one good major eruption minimum within the next 5 years is my prediction.
I got another question.
It should be max 5 years.
We got some good questions tonight, but Adaptive Dave, second question for Lee. Normally we would go through a first round for everyone, but this is a pretty good one here. Where will there be a telltale warning signs prior to a solar EMP? Wattage fluctuations, coronal tip changes, etc. Any signs we can look for so we know to seal our Faraday room?
You better have a damn Faraday room closed now. Okay? When we get between 30 and 40% of the solar wind speed, according to my calculations, that's when it can transpire. From there, anywhere down below that. I do not see it going as low as 18. There are some people who have guessed it goes as low as 18. I have not seen anyone be able to keep a plasma ball sustained down to 18% of the original glow voltage. Just doesn't, I've never seen that. 30 to 40% is where that normally transpires, is where it jumps back. So, or changes state. So I don't, the way I see it is, if you want to protect something, just go ahead and put it in your cage now. Put it in your double line trash cans. And if you want a number to look at as far as the wattage of what you will see at the top of our ionosphere, you can look at between 14,000 to 140,000 watts per square meter of the pulse is my calculation, to give you some kind of idea of what you're going to be dealing with.
Right. Another question, Billy the Fish asked, do we have any data that tells us what Earth's magnetosphere was doing during the Maunder minimum?
Absolutely. It was just like it was 50 years ago. Hasn't changed. Our magnetic field has only recently started to change by any amount. And we've got that marked all the way back to the 1800s. So yeah, we're basically exactly like we were. The movement of the magnetic field is only a recent event. Actually, as far as I can recall, it hardly noticeable until about the 90s.
Okay. Trying to see if we have any more questions here. I think that's close to it. Right, Mari, did I skip anybody on the questions?
If you skipped anybody, hit it again. We'll try it again, because I want to try to get everybody's questions answered.
Well, let's go ahead and roll the rest of that video, because there is a presentation that we wanted to show everybody. It's about 4 minutes and 43 seconds long. Mari, if you wouldn't mind, go ahead and get that rolling. But I thought it was key. This guy's name is Jan Thart. He has been mentioned a few times in our comment sections from different subscribers. We have a very diverse field of subscribers here, and we get a lot of great suggestions on channels to check out. So, and we came across this video here, and I'll go ahead and shut up and let everybody hear it.
Mini Ice Age and Ice Age raw data. The image you see on the screen now is a reconstruction over the last 400,000 years based on ice core samples. As you can clearly see, it's that we are currently in one of the warm peaks. These warm peaks make up 10% of the climate over the last 100,000 years. And according to studies which has been done on C14 levels, we are currently 500 years overdue from another major cooling cycle.
And he means a carbon-14 level for C14.
Okay.
The image you see on the screen now is a reconstruction of Earth's climate over the last 12,000 years. Over the last 8,000 years, the mini ice age phenomena has been increasing, while the warm peaks has been decreasing. Overall, the average temperature over a 1,000-year period has been decreasing. The next image you see now is the long-term trend over Greenland. The
This
graph
is the one I was talking about.
from Greenland ice core samples, hidden in between the warm and cold snaps, is a long-term cooling trend. In other words, Iceland is actually getting colder, not warmer as they would like you to believe. The next graph shows solar cycles over the last 400 years. The current solar cycle is expected to either be a repeat of the Dalton minimum period or the Little Ice Age period. The next graph is a graph of La Ninas and El Nino events since 1950. The graph clearly shows an increase in El Nino events and a decrease in La Nina events since 1977, when past and current sunspot averages surpassed 110 spots at solar maximum. According to the 50-year delay theory, this should continue till 2049, when the past solar forcing influence and projected solar forcing drops below 110 sunspots at solar maximum.
Which we're there now.
Okay, the image you see now is the average weather patterns during El Nino events. Since El Nino events is expected to occur more often than La Nina events till 2049, one can use the image to plot a basic forecast up to the year 2049.
And so this is where we're talking about that some areas become warmer during an ice age?
The image you see now is a combination of sunspot counts 57 years back and the current sunspot counts. Unlike CO2-based methods, the sunspot counts on its own, and solar cycle length methods, this method follows the temperature measurements very closely. In fact, of all the methods, this is the only one which predicted the so-called climate pause. Okay, the image you see now, the blue line on the image, is the projected solar forcing till 2070. It is based on a projected Dalton minimum reoccurrence. So obviously, if it's a Little Ice Age reoccurrence, it will look different. It will be even colder.
I can pause it right there.
Does not account for El Nino.
Okay, go ahead.
Okay, now this is the one thing that I stick out in every single one of my arguments against the people who run the models. Even if they run the models, and this is the solar forcing, this is where it would take us if we just had the solar forcing. But everybody and all the models leave out the aerosols and the effects of the galactic cosmic rays on increasing the particles and for the cloud seeding and the hazy skies. They leave that out, that we have more of that now than we had during the Dalton minimum and the Maunder minimum. So simply, even if we do have the exact same conditions as the Dalton minimum, and I don't believe we will have the same conditions as the Dalton minimum, I think we will go deeper than the Dalton minimum, because if you look at the dive in the TSI and the sunspot counts of the Dalton minimum, and you look at the dive that we're diving into now, in the Dalton, we would have already started pulling out. So we would only be scraping our nose on the bottom of the pool. We're going deeper than that. So we're going to thunk in the bottom of the pool. And if we don't start pulling out soon, and I say within the next 3 years, we're going to give ourselves a spinal cord injury when we hit the bottom of the pool, because we wouldn't have pulled out at all. So that's the scary part, about this, is that when you look at all of the models, everybody said we would have pulled up by now. And it's like nobody's even touching the stick. In fact, it's nudging over, because we're falling faster than the Dalton. There is no other minimum that I can find in history that we are falling at a faster rate than what we are right now. And at no time in history have we ever dropped in wind speed, dropped in sunspots, dropped in wind speed, dropped in sunspots, and dropped in our electromagnetic voltage potential difference between our ionosphere and space. We've never had a weakening ionosphere like we have now, and we've never had these crazy activities taking place in our Schumann resonance either. So there are a lot of things that are going on that are much different than anything we have ever seen before.
So I got an individual in the chat who doesn't believe that he needs to hear about previous information of other minimums, that everyone's only interested in what's happening to our sun right now. And, to answer that question, this is all history-based research. So to get an understanding on what's going to take place, you kind of have to give a history lesson.
Well, you have to. That's the only comparison you have.
Yeah. So there's no crystal ball to look into. Don't let anybody tell you that there is, because this is a type of research that is clearly on the fly. This is definitely, some scientists are saying it's an unknown grand solar minimum, which means it could be just a 42-year cycle, or it could be like what you and John Casey are saying, much, much longer, to the point where we won't come out of it during our lifetime. So I really,
basically, because of the galactic cosmic rays and the increase of the amount of galactic cosmic rays between now and 2100, it won't matter if we come out of it or not. We're still going to cool. There's no way that you can have that increase in galactic cosmic rays and still have man living on this planet, putting aerosols in along with all of the other aerosols that are being put up there, and not be cooling with that amount, even if we didn't have a grand solar minimum. Forget a grand solar minimum. Let's just say the sun was a constant. Okay, let's agree with the IPCC for once in our life, okay, and say that the sun is a constant. Even if it was, we would still get cooler because of the increase in galactic cosmic rays coming into our atmosphere. So that's going to increase even if the sun didn't get weaker. So we would cool no matter what, because of just the simple trends. I mean, look, in 2.5 years, we're already up 13% in galactic cosmic rays in the north central part of the country. We're up 19% in the northeastern part of the country. That's in 2.5 years.
We're seeing it. We're seeing it firsthand. I mean, the clouds are so thick too from it that the minute the sun goes behind them for a long period of time, you feel the temperature cool down. And the minute that the clouds break and the sun comes out, it's an instant heat up. So we're seeing it firsthand. We live in the New York area and definitely see evidence of galactic cosmic rays every day, cloud nucleation. Lee and I have several conversations on a daily basis almost about, I'm taking pictures or I'm asking him questions about what we're experiencing just on Friday. And I've got some footage. Lee, I'll send it to you. But I footaged some of the storm that we had on Friday, 10 minutes of downpour rain. And I've never seen this, not even in Ohio, where it just steadily poured for as long as it did, and how quick and how much rain fell. And it looked a lot like those dark clouds with the rainbow for the atmospheric compression. And as soon as the first lightning bolt hit during that storm, that's when everything unleashed and just drenched us. And I guess, here's the thing, a million-dollar question, and I'm jumping out of line to answer this one. Why is the sun weakening?
Well, the sun has its 206-year cycle. But the sun, everybody has always taught that the sun was internally powered. And it's not. It's externally powered. And that power comes in through the north and the south of the sun and radiates out through it. And Dr. LaPlante's research shows that. The Sapphire Project shows that. Other plasma experiments done throughout the world have shown that. So, if it were a continuous thermonuclear explosion, fusion, there's a couple issues with that are easily proven. First off, if you look at the frequencies of light and energy that a continuous fusion reaction would emit, you'll find that they don't match what the sun puts out. You'll find that the sun matches what plasma puts out.
Right.
When you look at the characteristics of the surface of the sun and you do helioseismology and monitor how it waves and undulates and so on and so forth, and how the holes are created and the magnetic umbrals come out and they snap and you get pulses of X-rays and so on and so forth. Fusion doesn't quite work like that. Plasma does. When you look at the way that the energy is dissipated out of the sun, if it takes, thousands of years or whatever it is from they say that it gets to the core and it's under massive pressure and it comes up to the surface. Well, when you have a coronal hole open up, you would think that because you would be able to see deeper into the sun towards that fusion, that it would be hotter there. We know that it's not. It's actually, over 1,000 degrees cooler in Kelvin in some places, a couple thousand degrees cooler Kelvin.
I want to interrupt you real quick. A comment in the section, Tony says, is this the opposite of Al Gore's claims of global warming? We'll be forced to pay more tax to fix it. And the difference here, Tony, is that there is no fix for this. Just like,
and the difference here is also we're speaking the truth.
Right.
This is not manipulated data.
Right. Al Gore claimed that there was something that we could do to change global warming. And the fact of the matter is what we're reporting on here is this is not anything we can stop. There's nothing that we could do to prevent the grand solar minimum. I mean, it's here.
Right.
It's a cycle. So
I did the calculations a year ago, and I took the total output power of all of the nuclear reactors, all of the electrical power, and all of the barrels of fuel that are harvested, as well as all of the coal that is harvested. And I converted that to say, okay, if we take all of that energy and we took every single bit of it and we ran that into giant electric heaters and had them all over the planet, we still could not, if we used every drop of oil that we pull out of the ground, every pound of coal, all of our nuclear energy. I didn't calculate taking nuclear warheads apart and things of that nature or whatever to try to make more nuclear reactors. I just took what the world's energy budget was and calculated up that in heaters, and we wouldn't be able to heat it enough to fight it. So if we took all of our efforts, we couldn't do anything about it. First, we couldn't afford it. Two, the grid wouldn't support it. And three, nobody would have any fuel to do anything else in the world, so we would all starve to death in a matter of 90 days. So it wouldn't matter. We don't have enough power to change this. So they can say, try to create a carbon tax or try to create a cold tax or whatever. It's irrelevant. There's nothing anybody can do to stop it. This is something that the sun is doing. What you have to understand is the sun puts out 44,500 watts per square meter. Okay? That is 20 times more power than your house uses on average. So when that gets to our atmosphere, stratosphere, the outer parts of our planet, that comes in at the TSI that we talk about of 1360 point whatever it is. The other day it was 0.1. I think it's jumped back up a little bit now. But still, that energy level is very substantial. And again, that's still 1,300 watts per square meter coming in, hitting our planet. That's a lot of energy. And we don't have anything that can touch that. The closest I've ever done to being able to touch that was when we were testing 500 kW generators. They're 0.5 megawatt generators for the military. And we were testing 3 of those at the same time at Aberdeen Proving Grounds. And we were able to heat part of the little island area that, along the area. I'd say there was probably 25 acres, because we were taking 100% of that energy and putting it off in heaters to dissipate it so we could put loads on the generators. And we were only heating, 25, 30 acres there with those 3 giant generators running simultaneously. So that was 1.5 megawatts. And we were only heating 20 or 30 acres. And that was only by about 3 or 4 degrees. So that's what I'm talking about. It's not doable. We can't stop it.
Right. We're going to go ahead and keep the video rolling here as we're going through time here. So let's go ahead and run through the rest of this video there, Mar.
The findings is as follow. 2017 till 2025, the average temperatures worldwide drops. From 2026 till 2037, average world temperatures increase, but remains below 2016 levels. With other words, it's colder than it was last year. From 2038 till 2048, average world temperatures drops once again, but it remains warmer than it is projected to be in 2025. In 2049 onwards, La Nina events starts to occur more often than El Nino events. With other words, that automatically means a drop in world temperatures, measured temperatures. 2049 till 2057, a new climate pause occurs, but it's colder than the pause we have just experienced between 2003 and 2016. From 2058 till 2070, extreme cold weather grips the planet, and it might be the start of a full-blown ice age. In other words, from this point onwards, from 2058, from 2070 onwards, you may have runaway global cooling, and we will go from a mini ice age into an ice age. That's all I have for you today. Thank you for listening.
All right, so again, just another video to share with everyone. I've had several requests about this gentleman. People have suggested things to me, and just watching a little bit of his stuff, he seems like he is definitely on board with the same theory that we have as far as global cooling and what's happening right now during this grand solar minimum. Lee, I'm going to wrap it up here, but I wanted to ask you if you had any closing comments for tonight.
Well, the one thing I did want to interject there is he did not also put in the data for the AEMO, the Atlantic Multi-Decadal Oscillation, and the PDO, the Pacific Decadal Oscillation, and the fact that, if my memory serves me correct, both of those are trending down now. So as they trend down, they are a substantial amount of the water on the surface of the planet, and they will have a cooling effect as well as they move downward in their cycle. So I think that'll push it down even just a little bit more than what his numbers are showing on the near term.
Guys, a lot of questions in here about the sun and cycling and everything like that. We are going to talk more about the sun on Thursday night. Leah's got a great presentation to share with us, and with commentary over top of that as well. Lee, thank you again for joining us tonight with the big picture with Lee Wilbarger.
Thank you for having me.
And we will see you guys Thursday night at 9:30. And like I said, Lee and I will be discussing. Lee, what's the name of the video that we'll be talking about?
To be honest with you, I can't remember what the name of it is, but it's from Wolf Witte from Canada.
Ironically, that name just came up in the chat. Someone just asked, when are we going to have him on to talk to? So ironically, there's your answer. We're not going to talk to him, but we're going to show a video that's by him and discuss what he is presenting as well.
And the crazy part about it is Wolf and I agree on a lot of things.
Nice.
Our research has been very, very, I don't want to say parallel, but we have come to a lot of the same conclusions through our own methods, which is, to me, very positive to find that I'm not the only person that is, one, doing the research, but is, two, coming to these conclusions based on the data that the instruments is giving us, and based on knowledge of plasma physics, the EU theory, and how the sun interacts with the Earth and the other planets. So I very much admire Wolf's work. I have for a number of years, and have recommended people to view his videos. Some of them are a little long-winded, and some of them are a little dry, but it is good information. He has some very good ideas for how we can save humanity. I don't think all of them are achievable. I tried to do some calculations of what he was trying to do originally, and at this point in time, I don't think we have enough time to achieve it if everyone on the planet even tried.
Right.
So I think we're past the point of no return of Wolf's dream. And, you know, I hate to tell Wolf that, but that's how I feel. And I think Wolf is realizing that as well. And so he's slightly changing his tune as far as what he's preaching now. He's just trying to get out the information to say, look, folks, this is what's happening. And you need to, you know, each man for himself.
Right. So maybe there will be a future opportunity where we can reach out to this young man or this gentleman here and discuss, have you and him discuss some things. All right, guys, thank you again for joining us. We will be back Thursday night, 9:30, to discuss one of his videos. We'll see you guys then. Take care.
Thanks, folks. Keep the questions coming. Okay, well, you know, and then, you know, we've had, you know, in 1640 to 1750, you know, rivers, the Thames, New York Harbor were all frozen over, you know, or the Thames, you know.
Yeah.
So we've had a variety of this type of weather in the past. We're not talking about anything that has never happened before. What we're talking about is this one here has a good chance of being worse than the others, just simply because of the contributing factors and where we are within, you know, our cycles. And so, you know, there's a variety of different things, you know, so where we are, the decrease in solar activity that we're having, the increase in vulcanization, as well as an increase in seismic activity, the gravitational pull of the gas giants, and more than 50% of the planets being on one side of the solar system, aerosols in the atmosphere, you know, that are interacting with galactic cosmic rays. So there's, you know, a lot of things that are going into this.
I was looking at this video, and there's a lot of information. I wish there was a slow-mo video motion. Show back to the first, the second part there. I think it was number 2 on our. There's a delay.
Solar activity?
Yeah, solar activity decrease.
Okay.
I wanted to.
Meters, whether that be a gas or what have you, anything that is that size, even a molecule can work as a seed for a raindrop. And so what you're seeing is as the particles are coming down through the atmosphere and they get to the right altitude for the right barometric pressure, the right temperature, the right amount of humidity, they are drawing that moisture in an atmospheric compression, because this is how it works. The particles come down, and as more particles come down on top of one another, you get layers and layers of moisture. And so as that bottom layer is working its way down, that's what you're seeing is the light is just catching the bottom of that layer. You're not straight onto a layer of moisture where it gives you a very defined rainbow where you're looking straight in. We're looking at a layer or a wall of water that is more horizontal, or a layer of moisture that is more horizontal than vertical. And as the light hits that, you get this diffused rainbow like you're seeing right there. It's not as sharp and as defined because it's not just moisture all the way to the ground. That's why it looks that way and diffuses as it goes off onto the horizon.
Yeah, and it wasn't raining at the time, and I also saw another comment in the comment section. They also seen a 2 cloud rainbows at the same time this week, no rain. So again, that was more than likely, again, what they were witnessing was the atmosphere. Welcome back to the Grand Solar Minimum channel. Today is August 6th, 2017. Quickly wanted to go over solar conditions. Our solar wind speed sitting at a 558.9 kilometers per second with the density right around 5.1. And we were feeling the effects from the coronal hole that we had from August 4th. That is well exited to the left. Looking at sunspot number AR2670, which once was 2665, much smaller as well. In fact, when this came back around Earth side, it was only a fifth of the original size. Looking at KP indices right around 2, the 24-hour max was unsettled. And of course, currently looking at the SDO, we do see another small coronal hole in the equatorial region. I can only imagine that we will see the effects from this coronal wind stream within the next 3 to 4 days. So, Lee, thank you for joining us. It feels like it's been a while.
Yeah, it has been a little while. Can you bring up your audio just a little bit? I'm having a hard time hearing you.
All right. Is that any better?
Just a little bit, yeah. Thank you.
All right. Sorry about that. All right. So tonight we have a couple things for everybody. We have a couple of videos we wanted to show that talk about the key factors of the Grand Solar Minimum. And first, I want to start off the show with some images that I had snapped myself here in Western New York. And this was not a normal rainbow. It didn't have the arc that most rainbows had. And I immediately snapped a few shots of this and called Lee. I hadn't seen a rainbow that was situated the way this one was. Is that up, by the way? So basically, I was just wondering, Lee, if you could pause that right there for me, Mari. This was what I took right here, and if you could, Lee, just describe to everybody, this wasn't the typical rainbow. There was no rain falling at the time, and this was not at sunset either. So just if you could explain to me, everyone, what we were looking at here.
So what you're seeing is you have particles in the atmosphere at a high enough altitude, a high enough humidity, and the particles are large enough from 50 nanometers up to 100 nanometers.
Compression coming down. And Lee, we've got this little clip of video that Lee had brought to me. Basically, this talks about different factors of the grand solar minimum. Lee, have you reviewed this video?
Yeah, just once. Basically, all I was doing was looking for something that just gave us the main contributing factors to what will be coming in the grand solar minimum. And so this video covered some of those. And so, I figured it would give us some data points here to look at while we were going through it and while we were talking about the different contributing factors to the coming colder climate. So, that we're in our third major cooling period in the last 2.5 million years. We have ice on both the north and south. So technically we are in an ice age because we do have permanent ice on the planet. Okay. There have been times where there is no ice anywhere on the planet, and there have been times when they had ice all over the planet. So pause it right there.
Okay.
So you can, that was our first mini ice age. This is the second mini ice age. So you can see back there, that was the first one in 1650. And then we've had another one, since then. And when you look at the charts that we'll get into here a little bit later, you'll actually be able to see the curve that I'm talking about and the decreasing energy within our solar system. And so, yeah, there's a mini ice age. There's another mini ice age back in 1850.